Welcome to Vision Plus and welcome back to S.4 Mathematics. We are looking at differentiation and now we want to see how we can differentiate given functions or expressions using first principle. Example 1 says, differentiate the following from first principles. Part A says that we are given a function y equals to x plus 1. Now we need to differentiate that given function from the first principles. What do we do in first principles? In first principles, we have a formula that says, this is the formula that we employ here. Now the formula says that dy dx equals to limit as h tends to 0 for the function f of x plus h minus the function f of x divided by h. This is the formula that we use when we are dealing with the first principles. Now, what do? We simply need to get these expressions. We need to get fx plus h and f of x. Those are the simple expressions that we have to get. That means, therefore, we have our function given as y equals to x plus 1. Okay? This is the function y, which is defined in terms of x. So we can say let y be the function f of x as it is, because this is the function y, which is a function defined in terms of x. So it means that this y is the same as the function of x. The function of y in terms of x is given as x plus 1. So simply, what do? You simply change y to f of x as it is here. Now this means that we have f of x already, which we are subtracting away from here, minus f of x. It is there. So we have this one term that will be important to use in the formula. The other term that we need to pay attention to is fx of h. F of x plus h. Therefore, for us to get f of x plus h, remember this is the same function. This is the same function. That means here was x. So in this case, x now, in the first case, corresponds to x plus h. So what do? We use this function, this right hand side of this function, x plus 1. But instead of x here, we shall use x plus h. So we are going to substitute. What is x? X now is x plus h. In the position of x here, I have put x plus h. Then I proceed there, I have there plus 1. That is what we do in functions. It is just like if you have a given function, maybe f of x equals maybe 8x plus 1. How about f of 2? It means this 2 now has become the value of x. So it is simply 8 times that 2 plus 1, giving us here 17. So it is the same case here. F of x is the original function. Now what if x is given as x plus h? So instead of x here, we substitute for x plus h, and then we proceed. So if you look here now, we can take away the brackets so that here we have x plus h plus 1. This is now f of x plus h. So therefore, we have f of x and we have f of x plus h. So we simply come and substitute for them in the formula. So let me go up there. Therefore, dy dx equals to Don't forget to say limit as h tends to 0 for, we shall look at what we mean when h tends to 0. Now, we need to substitute what is f of x plus h. F of x plus h. F of x plus h is here. That is, it is x plus h plus 1. That is f of x plus h, which is this. But we are saying subtract away f of x. What is f of x? F of x is x plus 1. If you look here, there are two terms. Always when you are subtracting away two or more terms, you put them in the brackets. So we shall say minus open bracket x plus 1, close the bracket, and then you have a bigger bracket of the formula there. But we are saying over h, so we divide this by h. That is the formula. So we simply need to simplify the numerator. That means we shall have limit as x tends to 0 for the function. We shall have here x plus h plus 1, and then you open the bracket here by negative 1. So we shall have here negative x minus 1, because this sign affects x, also affects 1, become negative over h. Then we simplify further. Don't forget limit as x tends to 0 for. Now you are seeing that x and x are cancelling out because this is positive, this is negative. We are also seeing that 1 and 1 are cancelling out, right? Yes. So x and x will cancel, 1 and 1 will cancel. So we shall have h over h, right? What is h divided by h? Limit as h tends to 0. What is h divided by h? It is 1. Okay? If you look at 1, that 1 is independent of h. In other words, I mean this this one here is not attached to h. So whether h becomes as small as 0, it doesn't affect the value 1 because it is independent of h. So in this case, since it is independent of h, we shall not substitute for h as 0. So we simply say therefore this gives us 1, and 1 is the answer. So therefore dy x equals to 1. We have differentiated it from first principles. But you can check whether your answer is correct or not. How? Because you already know how you deal with powers and coefficients. So if we differentiate this using our knowledge of powers and coefficients, this is just a side check, so that you leave when you know that you are passed. Now, we say that if we are differentiating using powers and coefficients, we say this one has a power 1, so we lower that 1. There is existing 1, so we say 1 times 1, right? Now, x, what is the new power? The new power becomes the old power minus 1, and then plus. If we differentiate the constant 1, it gives us 0. That means here we shall have 1 times 1 is 1, x power 0 plus 0. Any number to power 0 is 1. 1 times 1 is 1 plus 0, which is 1. So our answer is correct. Okay, our answer is correct. So that is the solution to part A. Let us go to